Hello everyone and welcome to the Dragon Code. In this video I will build a program in assembly language that will convert decimal number to binary number. In register R1 I will store input number, decimal number. In R4 I will pop numbers from stack. It will initially be 0. In R5 I will store a result. It will also initially be 0. In R9 is going to be counter. In R11 I will store 0 to add 0 if remainder of division is 0, and in R12 I will store 1 if remainder of division is 1. So it is input number, result, counter, binary 0 and binary 1. Then I will add new branch. I will call it push binary, and here I will first move in R2 value in R1, then I will do logical shift to the right in R2 for one place, and then logical shift to the left again in R1 for one place. And I will compare R1 and R2, and if they are equal, branch equal, I will move to store 0 branch. So if they are equal, I will store 0, so I will add that branch. Here I will first push 0 on stack, so I will push R11 on stack. Then I will divide R1 by 2. It is logical shift to the right by one place. I will increase counter R9 plus 1. And then I will go back in push binary branch. And if R1 and R2 are not equal, remainder is 1, so I will store 1, and I will copy this, and I will just change here R12, so I will push R12 on stack, and result value in R12 is 1. And I need one more thing in this push binary branch. I need condition when I will terminate this loop, so I will terminate this loop when value in R1 is equal to 0. So I will compare R1 with 0, and if they are equal, branch equal, I will go to branch pop binary. And I will add that branch here. In pop binary branch, I first need to pop first value from stack, and I will store it in R4. Then I will multiply value in R5 with 10. So I here need another register to store 10. So in R10 I will move 10 to multiply with 10. With 10. So here I will multiply value in R5 with 10. And then I will add in R5 R4. I need to repeat this process, so I will go back in branch pop binary. And now, because this branch will be repeated, I need to specify condition for termination. For that I will use counter So I will decrease counter after each iteration, R9, R9 minus 1. And I need to compare R9 with 0. And if R9 is equal to 0, branch equal, I will go to exit branch and I will add exit branch here. There's nothing in exit branch, it is just for ending program to escaping this loop. And let's now compile and load this program. I will change format to decimal sign. I will go step by step. So in R1 is 10. Now I go in branch push binary. R1 is not equal to 0, so I will continue. So R1 and R2 are equal, branch equal, so I will store 0 on stack. I will push 0 on stack. Then R1 and R2 are not equal, so I will push 1 on stack, and so on. Until in R1 is 0. Now in R1 is 0, so I will move, here is comparison, so I will move in pop binary branch. So now I will pop values from stack, and it is done in reverse order. This is the way stack works, and this is exactly what I need for binary number here. So in R5 it is first 1, it is 10, 100, 101, and 1010. And this is end of this program. So in R5 is result, and here is 1010, and this is 10 in binary system. So this program works. Let's try with another input number. Now I will write here 14, and it should be 1110. And let's see, will it happen? I will move faster through these steps. And in R5 should be 1110. It is end of program, and in R5 is 1110. It is 14 in decimal system, so this program again works. This is all for this video. If you like this video and want more videos like this, press like button and subscribe, and see you next time.